There are the review, the first three. So that's what we started yesterday. So things to remember, this is back from math junior high. You expand every term in the brackets by -5. So nothing to collect because in the brackets there's no like terms. This is what we did yesterday. Two binomials together, you get 4 terms, collect like terms. If you're getting really good at it, okay, you can add those like terms in your head. I don't have to see this first line of work, okay? But if you are still struggling, don't skip it, right? But if you can add those like terms in your head, do it. This one here, I strongly recommend for right now that you show it as the product of two binomials and then expand it out. Because what I see so often from students is I get this, either 1 plus 9m squared or 1 minus 9m squared. Either one is incorrect, okay? Students forget that you're squaring the whole binomial, so it's two of them together. There's adding inside. It's not just a monomial squared, where you square each factor. This has terms in it. So I strongly recommend that you show it as the product of the two binomials, right? They're exactly the same. Then you expand them out. If you can do that expanding in one step, adding the like terms in your head, go for it. Take a look at, why do you think I wrote it like this as well? What's the difference? Totally. Degree, exactly. So I rearranged it to be in descending order of degree, highest degree term down to lowest, which is best form, right? It's not wrong if it's the other way, but it's best form. Certainly if we say put in descending order of degree and you don't, then you're not going to get full marks, right? Because we're prompting you to do it. Okay, so let's take a look at the next question. So it says, is this polynomial here in factored form? Well, I've said before, if it's got brackets, then it's in factored form. But the ones that I said that for only had 2 sets of brackets. They're pretty straightforward, two binomials together. Now, here I have 2 sets of brackets. I have a bracket squared, and I have a subtraction in between. So really, this is 2 terms. It's the one clump minus the other clump, if you think talking about them as clumps. And so that is not factored form. Basically, you have to have bracket, 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 bracket all the way through somehow to be in completely factored form. So this was factored because there was no adding in between. That one's factored. This is in factored form. This is in factored form. But this is not because of that subtracting in between the brackets. Okay? So no, as it actually has 2 terms. And if it has terms, because terms are separated by adding and subtracting, it's not considered to be in factored form. Yep. Oh, in the last one? No, but if we prompt you, yes. Okay, but you should try to get into practice of doing it, but it's not wrong. Okay, so this last one, so we said no, it is as it actually has 2 terms, so it's not factored form. Doesn't mean that we can't simplify it. We just have to do it in steps. So I want you to expand that out, and I want you to expand that out, and then you're going to subtract. So it requires more work. So basically the same concepts from yesterday, but you have to do more of them within a question. So here we'll have, oh, not 6, sorry. We'll have 3x squared plus 15x minus 2x minus 10. I can get rid of the brackets because It's the first term. There's nothing in front of that bracket. Now, saying that, I'm subtracting, and this is a binomial squared. So I need to keep that answer I get in brackets. If you want to do that squaring of the binomial by showing it as a product, I do that on the side. So I go, okay, x minus 2 times x minus 2. Basically, in my first line of work, I want all the expanding being done. So here, when I do this part, I get x squared minus 2x minus 2x plus 4. And then I put it back in here, and I can even collect like terms as I do that. Okay. Mandatory to have brackets around that, because you're subtracting everything in the brackets. So you're taking out the x squared. You're taking out the negative 4x. So when you take away a negative, it's like adding. If you take away a positive, it's like subtracting. So it goes back to when you learned integers. When I taught integers before, think about when you get rid. Think about negative being sick, feeling sick. Okay, positive feeling healthy. So if I get rid of, subtract, feeling sick, do I feel good? If I take away, yeah, you feel good. You've recovered. It's like adding. Positive. It's a positive thing. Right, McKay? Are you feeling better yet? A little? Okay. But if I take away your good health, what do you feel? Sick. Right. So you are changing the signs. Oops, there we go. So here, oh, I wanted blue. So here, 3x squared, I can collect like terms. And then this will be minus x squared plus 4x minus 4. And again, you've kind of done that work back in junior high, but this is a step further in that you had to square those binomials, that binomial first. So this, okay. So this is a plus, this is a minus. So this here went to be from a negative to being positive, a positive to being negative. This x squared was positive, and so when you're subtracting a positive, it's subtracting. It actually looks the same, right? Because it was positive to start. So now when we collect like terms, 3x squared minus x squared is 2x squared. 13x plus 4x is 17x. Negative 10 minus 4 is negative 14. Okay. Typically, when all the brackets are in descending order of degree, it will end up in descending order of degree if you multiply in that order. Okay. So remember how we talked about the area question from the last notes where we substituted 3 centimeters in? This isn't representing area, but as I mentioned, a way of checking is to substitute a value in. Okay? Value that you wouldn't want to substitute is 0, but anything else would be fine. So here it's 4 we're going to do. So substitute this into the original expression. So we're going to have bracket 3. I'll put the 4 in a sec. So I'm kind of putting brackets within brackets here. Minus. And so I'm putting in the 4. kind of a long way of checking, but it certainly is a method. As I said, next week, once we do factoring, it will be a little bit easier to check using a different method. So that's going to be 12 minus 2 is 10. You can do that in your head. Then 4 plus 5 is 9. 4 minus 2 is 2. It's an order of operations question, right? Once you substitute in. So that's going to be 90 minus 4 is 86. And hopefully we get the same thing when we substitute the 4 into the simplified form. So 16 times 2, always order of operations. Square that 4 first. So it's not 8 squared. It's 4 squared is 16 times 2 is 32. 17 times 4 is what? 40, and 28 is 68. Minus 14. So 90, that's 100, minus 14 is 86. Yay, they're the same. Okay, take a look at question 2. We did one like this yesterday. So we have 2 terms, a binomial, times 3 terms, a trinomial. How many terms, you told me yesterday, how many terms am I going to get when I expand this out before collecting like terms? Fingers up. Yes, 6. Good. 2 terms times 3 terms is 6 terms. So you're going to get 6 terms. So one set of brackets from the 2x, and then another set of brackets from the negative 3, or sorry, another set of multiplications. So you'll have 6 altogether, and then collect like terms. Okay, that's a little bit messy because I was doing it without, it was lagging. So that's 12x plus 15. Okay, so like terms. Use a different color. Use a different symbol if you need to. So there's only one x cubed term, but there is an x squared and an x squared. There's an x term and an x term, and then only one constant term in this question. So I'm going to put the cube term first because it's descending order of degree, or you should try to, and then the x squared. So negative 8 minus 3 is negative 11x squared. Negative 10x plus 12x is 2x plus 15. It looks like a 0.5, but it's not. Okay. So 6 terms. Part B, 3 terms times 3 terms. Hands up. How many terms will we get, Matej? 9. 3 times 3 is 9. So in this case, one set of brackets or multiplications that way. then the y times everything. I'll use, and then the 3 times everything. So 3 arrows, 3 swoops, right? So when I do that, I get 2x squared plus xy plus x. Then when I multiply the y, keep it in alphabetical order within a term. So that's a plus. So then for my red arrows, I have y times 2x, which is 2xy. If you put yx, you might miss that it's a like term with an xy term. Okay, so 2xy plus y squared plus y. So those are all the reds. And I'm running out of space. I'll put it underneath. I'll do the greens. And so that would be plus 6x plus 3y plus 3. So there's 9 terms. What are the like terms? Well, only x squared there. There's an xy term and an xy term there. There is an x term and an x term, and then a y term and a y term. Y squared, only one y squared term, only one constant term, only one 2x squared term. So remember how we said descending order of degree? Well, the x squared is degree 2, the xy is degree 2, the y squared is degree 2. So then I would think about alphabetical order. So I just pretty much the same order that it's given here. So 2x squared, I'm going to put the xy terms next, so that will be plus 3xy. Then I'm going to put the y squared term, because those are all degree 2. Okay. Then I'll go back to degree 1 and do alphabetical order. So x plus 6x is 7x. Y plus 3y is 4y plus 3. Okay. Remember yesterday how I said attention to detail is really important in math. So in the old days, when a job was posted, it would used to be put in the newspaper. And a lot of jobs, it would say, you know, what qualities they need. Someone needs good attention to detail. Same thing for a math student. What qualities are needed, particularly as you go on, if you go on to 20-1 and 30-1 in calculus, if you drop an exponent of 2 and make it a 3, that's going to make, that little error is going to make your life miserable and sometimes very challenging to do the work, right? So it seems little, negative to a positive. Certainly if you're dealing with money, do you want positive amounts of money or do you want negative amounts of money? I think you want positive. Negative means you're in debt. So you don't want to mess those up. So attention to detail is really important. Okay. Next one, very similar to A, except it's 3 terms to start and 2 terms in the second one. So 3 terms times 2 terms, how many terms when you expand out? 6 again. Okay. This time in the brackets, you'll notice the leading coefficient, we call it the first coefficient in the brackets, is negative. It's not really our favorite, but that's not, this is just the question. It's not your final answer. So we just take it as is. And so you have a choice. You could do 3 sets of arrows, here to here, here to here, and then the second term and then the third, or you could do the arrows from the right-hand side. Because this is the same as
3x squared minus 4y times negative x minus y plus 1.
The order of the brackets doesn't matter.
You could switch the order of the brackets. Oh. Why does it not like to change here? Okay. So negative x times 3x squared is negative 3x squared. Okay, then negative x times negative 4y is positive 4xy. Negative y times 3x squared is negative 3x squared y. Oh, what did I do wrong in the very first term?
My attention to detail was terrible. I made that mistake.
It's cubed. Oh, see, I shouldn't even talk about it because then I make a mistake. That is a 3. Whoa. And then what did I do? No, then that's fine. Okay, so then here, and then plus 4y squared. And then plus 3x squared minus 4y.
If you need to use scrap paper because your writing is really big, go for it, right? There maybe if there's not enough space in the practice, get a piece of lined paper, okay?
All right, let's take a look at this in terms of degree and such. So that's a degree 3 term. This is a degree 3 term. So we're going to put those two terms first. Just the x cubed term first because it's just x, alphabetical order. So then minus 3x squared y. Okay. Then squared terms. So then alphabetical order. So 3 plus 3x squared, then the xy, then the y squared, and then degree 1 term.
So nothing collects here. When we, so really, both of those lines of work that I have there are exactly the same. But the final one is in descending order of degree. There are no like terms in that one. Okay?
3x squared and 4x squared, 4xy, do they both have a degree of 2?
They do. Yeah, we talked about that yesterday, so you want to go through. XY, it's degree, remember from yesterday, is how many variables are multiplied together. So x times y, 2 variables. So it's degree 2.
Okay.
Five. Yeah. Degree 5, yeah. Yes.
No, it doesn't. We tend to do alphabetical order, right? So we did x's, just x's first, because x comes before y in the alphabet. And then, well, the only 2 choices here, that had a y, so that would go second. But between these 3, I start with the x's, and then there's still an x in xy, so I go that one, and then the y squared. So it's an alphabetical order is the second sort of step. Okay. Okay, so I took up so much space there. Let me see if I can kind of just move that a bit. take a look at D, there are 3 binomials. Okay, let me see if I can move this without, well, a little bit. It'll take too long, so I'm not going to worry too much. So here, what do you think I should do in D? First of all, how many terms do you think there might be before simplifying? Yes, 8. Sorry. 2 times 2 times 2. No, we're doing this one up top here. Yeah. So 2 terms times 2 terms, remember, is 4 terms. 4 terms times 2 terms is 8 terms. Now, is it going to stay as 8 terms? If all the terms within those were like different variables and no constants, yeah, you'd have 8 terms. But there's the same. You've got p in each of them and a constant in each of them. So guaranteed there will be some like terms. Okay. Best step to do is to multiply 2 sets of brackets together first, then by the other bracket. Okay. Which 2 to do? Doesn't matter. You can do the first 2 together, or you can do the last 2 together. Okay? Or you could switch them around, do the first and the last. I wouldn't bother doing that, right? Don't make your life miserable. Personally, what I end up doing is I like to keep the first one the same. And then I distribute in the second 2. But it sure doesn't matter which. You will end up with the same thing. So here I would get 3p squared minus 12p, then plus 2p minus 8. Okay. Now, 2 terms times 4 terms, I'm going to get 8. But take a look in that bracket that I did. There are some like terms. So I'm going to collect those first. Saves me some multiplications. So I'm not going to multiply out the first bracket yet. I'm going to collect the negative 12p plus 2p first. Do you have to? Nope, you don't. Now I'm going to expand out those 2 brackets. So now I should have 6 terms, right? Because I've already collected some in there. So that's 6p cubed minus 20p squared minus 16. Just got to wait for that. I think I missed the 1. Just a sec. Oh, no, I got it. 16p. Now I'm running out of space. Guys, can you stop, please? And so for my next set, I'm just going to go underneath. And you can actually even line them up if you wanted to. Just works out that way. So now when I collect like terms, 6p cubed minus 23p squared minus 6p plus 8. So even though I thought I was going to have 8 terms, once I collect like terms, I'm down to 4. And that just depends on what's in the brackets. Okay, I'm going to leave this one, because we've already done one similar, for you to do in a minute. Okay. But once you've done D there, turn over to the last page for a couple of area application questions. Okay, so turn over think about what you're going to do to find the area of the shaded region. First one is a little rectangle in a big rectangle. Okay. Next one is a triangle within a rectangle. I always like to start out talking about donuts. Does anyone like donuts? Okay. Yep.
We find the area of both of them, and then subtract the area of both of them.
Yeah, the inside from the outside.
Inside
Yeah.
from the outside.
Yeah, that's why I like to think about donuts. Because back in the day, so you guys, you know what a Timbit is? Yeah. So back in the day, they weren't called Timbits. If you go to a different store, they're not called Timbits because it's not called Tim Hortons. They're donut holes. Why were they invented? Well, to make a donut, you make a big blob of dough and you take out this part of it, right? So you subtract it and then you don't waste it. You don't make Timbits out of it, donut holes, right? So you're taking the inside out. So that's my just silly analogy for donuts because I love donuts, okay? But same thing as Matei said, in the rectangle, you find the entire area of the whole rectangle. Then you find the area of the inside rectangle and you subtract it. What's going to be important is the brackets. You subtract everything from that inside rectangle, okay? And my thing stopped working, just like it does every day, it seems. So just give me a sec here. Use my finger. Won't be as nice, but so really what this is going to look like, area of the shaded equals 7x plus 5 times 5x minus 3 minus 2x times x plus 1. Okay? I'm taking up a lot of space because I can't use my stylus, I have to use my finger. So in any case, if you want to do it in steps, you can. You can do the outside rectangle here, inside here, and then subtract. I just put it all in one statement. A nice mathematical statement. Quickly. Okay, so now we're going to take a look at the first set of brackets. There's nothing outside, which means it's positive. So when I expand that out, nothing, I can get rid of the brackets. Okay. And then when I expand the next, notice how it's a monomial times a binomial. So I can get rid of the brackets right away. That would be minus 2x squared minus 2x. So you take that sign in front of the 2x and distribute it. So 35 minus 2 is 33x squared. Negative 21 plus 25 is 4x. Minus 2x is 2x. Minus 15. Guaranteed we'll have something like that on the test, right? Because that's an application question. So think about how to do B. Very similar. We've already done calculating the area of a triangle with algebra. Issue with that one, we need to figure out what the base of that triangle is. So here, we know the length and width of the rectangle. So for our triangle, okay, the height of it would be the same as the width of the rectangle. And then this here, well, the entire thing is 8x minus 6, and then the two little parts are both x. So 6x minus 6, exactly. So 8x minus x is 6x minus 6. So I'm going to put 6x minus 6 there. Okay, so in terms of the area of this, I'm going to, actually I'll put it underneath because I won't keep it very. So the outside rectangle, 8x minus 6 times 4x minus 3. Then I'm going to subtract, and then I'm going to have my base times height divided by 2. So 6x minus 6 times height, 4x minus 3, all over 2. Or you could put a half out front. Bless you. Where it's all brackets. I just got to see if I can. Oh, no, that's not what I wanted to do. Okay, so then, so here, when I'm doing the 24, I'm going to put brackets around that. Minus 18x minus 24x plus 18 over 2. So I need those brackets because I'm subtracting everything in the triangle. Sorry I have to write so big here, but my stylus has stopped working. Okay. Now, if you want to do this last step all at once, you can, but you've got to be really careful if you do. Maybe we'll do 2 steps because I don't want to mess it up. So I'm going to just move this down here just so it's easier for you to see. And then, so I'm going to have subtract here, and then collect like terms and divide by 2. So 24x squared divided by 2 is 12x squared. Negative 18 minus 24 is negative 42x. Divided by 2 is negative 21x plus 9. And then I get rid of the brackets, so the sign changes in all of those terms. So that's going to be 20x squared minus 27x plus 9. Whew, big one. Okay, that's a big question.
That's like a high level question.
Yep, for sure. Absolutely.
How does the negative 21x come?
Because you're subtracting everything in here. Right? It's like treating this as a negative 1 and expanding out. That makes it easier for you. Go for it. Treat it as a -1. All right, so still have a half an hour to do some practice and ask me questions. Remember, go back and do the question number 3. We didn't do that one. And then the practice in there and the textbook. Lots of questions there. Page 186, 195. And yesterday's. Okay?